so we're going to be able to describe multiplying. Try this again. By powers of 10 and convert scientific notation into standard form. So you'll notice that this seems like it's going to be really important because it's got the word scientific in there. And that's because this is a concept that you will be using in terms of science from here on out. We'll talk a little bit more later on about what scientific notation actually is. But first we need to understand the multiplying by powers of 10. So looking over here, I think you should absolutely be able to fill out this information from at least 10 to the 0 power and up. Without any kind of help or support from me. So please go ahead and take a moment to go ahead and fill that out. I'm just going to watch what happens while you do it because I've noticed a pattern of how people do this seemingly all day long. Okay, please check me 5, 4, 3, 2, and 1. So I did see a lot of people do the same thing that I saw this morning, which is that I saw a lot of people, they started with the 10 to the 1, and they knew that was 10. And then they actually moved up. Instead of starting at the 10 to the 4th and moving down, because they were like, oh, well, 10 to the 1st power is just 1 less than 10 to the 2nd power, so I have one more multiplication of 10 here. So I'm going to multiply by 10. So each of these is like a multiplication of 10. As I move up, I've got another multiplication of 10, an extra multiplication of 10. Then I've got one more multiplication of 10. That's going to give me 10,000. And so that's the method that I found a lot of people doing it. And that's the whole idea behind this next one is that each of them is multiplied 10 more than the next. And that's going to be a really important concept when we think about what happens each time we repeatedly multiply by 10. Now, 10 to the 0 power, on the other hand, is a different story. Anything to the 0 power is 1. Now let's move down to the negatives. Looking at 10 to the negative 1, we know that a negative exponent means that we're working with the reciprocal. We're working with the reciprocal here. And so that means we're working with 1 over 10. The next one is 1 over 10 times 1 over 10. Because the negative exponent tells us we're working with the reciprocal, and then we're doing it 2 times. That's going to be equal to 1 over 100, or 0.01. If we go back up here, that's going to be 0.1, so 1/10, 1/100th. And then at this point, you probably don't need to write out the repeated multiplications of 10 to recognize that it's probably going to be 1/1000th. And you see this again, this pattern of all these negative exponents for multiples of 10 are just meaning that we're multiplying by 1/10. One more time. 1/10,000th is 0.0001. All right. So when we come down to this, 10 to a positive power represents a repeated multiplication of 10. So when we have 10 to a positive power, it's just repeatedly multiplying 10. Now if we have 10 to a negative power, we know that's a repeated multiplication of 1/10. because we're working with the reciprocal if there is a negative exponent. The other thing we need to think about is how this we think about this relative to other values. We can think about this all in terms of its relative placement to 1. Anything that has a positive exponent, 10 to a positive exponent, is always going to be greater than or less than 1? Greater than. Obviously, and that makes a whole lot of sense, because if we're making multiplications of 10, we're making numbers larger. So we're going to be making them greater. And if we have 10 to a negative power, it's going to be greater than or less than 1? Less, because if we think about what's happening when we have the negative exponents for 10, that means we're multiplying by 1/10, which is the same thing as dividing by 10, which is going to make the numbers smaller and smaller and smaller. So if we're starting with 1/10, they're going to stay less than 1. So let's come over here. This is kind of where we're going to start to build that concept of what scientific notation is. I have 0.05 times 10. Everybody go ahead and do it on your paper. 0.05 times 10. Andrea B., what'd you get?
I got 0.5.
All right, she got 0.5. Now I want you to take that 0.5 and I want you to multiply it by 10 again. Point 0.5 times 10, what'd you get, James? 5.0, or just 5. 5 times 10 is 50. What is happening each time we multiply by 10? And this is the most important concept of today. What happens each time we multiply by 10? What happens to the number? Daryl. It gave it an extra 0 in a sense, but kind of over here it didn't quite give it an extra 0. We actually went from 0.05 to 0.5. What changed there?
0.
Yeah, the 0 disappeared because the decimal place moved to the right. And so what we can see here is we can see each time the decimal is moving once to the right. So every time you multiply by 10, the decimal moves once to the right. And this is what makes multiplying with tens really, really easy. Now, some people try to memorize which direction it's supposed to move, and they have trouble doing that. I was one of those people. I had trouble memorizing things when I was your age, so I had to kind of remember conceptually why that made sense. Now let's think about this really carefully. If we're multiplying by 10, why would it not make sense that the decimal would be moving to the left? Okay, why would it not make sense for the decimal to move to the left? I can promise you this is going to be a question on your test. Why would it not make any sense if I'm multiplying by 10 to move the decimal? And Adari, what do you think? Okay, you're thinking about the exponents. Okay, that makes sense. But we're not quite to the exponents yet. Yoel, what do you think? Why would it not make sense for the decimal to be moving to the left if I'm multiplying by 10?
Well, because the first one was moving to the right, it's gain more, and it's also negative. It won't make.
No.
So it wouldn't make any sense for it to move to the left, because if we're multiplying by 10, the number should be getting greater. So let's come over to this. 0.05 times 1/10. We could write that 1/10 as a decimal, 0.1. 0.05 times 1. What do we get? 0.05 times 1. 10th. 0.05 times 1/10. Sorry. 0.05 times 0.1. Felipe. 0.005. So what we can see here, and this should make conceptually a lot of sense to us, because if we're multiplying by 0.1, really it's just multiplying by 1, except there's an extra decimal place value. So all I'm really doing here is I'm adding an extra decimal place value. So 0.005 times 1/10. Anadari? 0.0005. Again, I'm really just multiplying by 1, but because that 0.1 has an extra decimal, I've got to move the decimal 1 time. Which kind of should be giving us the idea for this last part. What happens every time we multiply by 1/10? To me, this one's even more intuitive than the multiplications of 10. Najari? It adds one more 0, and I think that's okay if we think about that here, but if we think about 500 times 0.1, that is not going to be 5,000, right? Okay, so let's be a little bit more clear for something that will work for all numbers. That's definitely true based on the numbers that we saw here, though. Jalela. The value is getting smaller, absolutely. Anadari? The decimal moves once to the left. And this makes sense based on what Jalela was saying. The number is getting smaller. The value is getting smaller. And the only way that's going to work is just the decimal moves once to the left. Now, scientists caught on to this and they were like, ooh, I'm going to use this to my benefit because I work with these really large or really small numbers all the time. And I get really, really tired of writing all of the zeros at the beginning or at the end of these numbers. So scientists came up with scientific notation, which is a shorthand that uses repeated multiplications of 10 or 1/10 to represent very large or very small values. So scientists decided that they were going to use this idea to help represent very large or very small values. So let's look at how this works. I have a number down here. This is in scientific notation. It is a number between 1 and 10 multiplied by 10 to some power. That is scientific notation. Let's talk about why it works. 4.3 times 10 to the third power. Let's go ahead and write this in its expanded form. That would be 4.3 times, what is 10 to the third power in expanded form? Lolly? In expanded form? 10 times 10 times 10. So what we see is that this really just represents 4.3 times 10 repeated 3 times. Now, I could multiply 4.3 times 10, and then I could multiply that number times 10, and then I could multiply that number times 10, but we know something about what happens when we multiply by 10 now that should make this a whole lot easier. Because every time that we multiply by 10, what happens? Look back at your notes. Every time we multiply by 10, what happens? Look back at your notes. Every time we multiply by 10, what happens? Smile. The decimal moves once to the right. So if I'm multiplying by 10 3 times, what's going to happen? The decimal is going to move to the right 3 times for each multiplication of 10. So this really means all we need to do is move the decimal right 3 times. So I have 4.3 times 10 to the third power is going to be equal to 4.3, but each time I multiply by 10, I'm moving the decimal right once. So 1, 2, 3 times. Put in some placeholders there. I'm going to go back and delete my original decimal. And I see that 4.3 times 10 to the third power is really just a different way of writing 4,300. Now we can imagine if this number was even larger and it was like 4,300,000,000, that might be a whole lot faster way to write it as like 4.3 times 10 to the whatever than writing it out the long way. So we'll see a couple examples of that later. In science, we might use this to represent some really large numbers. For instance, the distance between here and the sun. It's millions of miles. Maybe even billions of miles. I actually don't even know the number off the top of my head. The distance between here and the nearest galaxy. Trillions of miles, okay? So we're talking about these extremely large numbers, all right? So that's what scientists will use this for. And so let's look at this. We have 4 times 10 to the third power. Is this number going to be greater than 1 or less than 1? It's going to be greater than 1. Right, because we have all these multiplications of 10. It certainly better be greater than 1. That's really just a check for us to think about relative value when we get our answer here. If I want to put this in standard form, I'm starting with 4, and then I'm multiplying by 10 3 times. If I multiply by 10 3 times, what's the easy way to do that? Najari. Yeah, so you're thinking about it as like, this is times 10, times 10, times 10. And what do I know happens each time we multiply by 10? It gets a bigger number by moving the decimal 1 to the right. So all I've got to do is identify that the decimal goes here. It's like $4.004. And I move the decimal 1, 2, 3 times to the right. Once for each multiplication of 10. So I see that 4 times 10 to the third is the same thing as 4,000. 6.3 times 10 to the fourth. I have all of these multiplications of 10. Is this number greater than 1 or less than 1? Greater than 1 or less than 1? All right. So we get that this is greater than 1. So we're starting with 6.3. And this 10 to the fourth power means I'm multiplying it by 10 4 times. Each time I multiply by 10, what's going to happen? I'm going to move the decimal to the right. So times 10, times 10, times 10, times 10. And I'm going to go back and erase my original decimal point so there's no confusion. That shows me that 6.3 times 10 to the fourth power is the same thing as 63,000. I'm going to put a little comma in there just so I don't get confused. Now 3.06 times 10 to the sixth, greater than 1 or less than 1? Greater than 1. And I have 3.06, and then I'm multiplying it by 10 6 times. What happens each time I multiply by 10? Move the decimal to the right. Okay, so 1 multiplication of 10, 2, 3, 4, 5, 6. Fill in my place values. And then I'm going to go back and erase that original decimal point. Then I'm going to add some commas to make this number easier to read. So I see this is 3,060,000. All right. So now let's talk about scientific notation with negative exponents. What does that negative exponent mean? What does that negative exponent mean? Isais. Yeah, we're working with the reciprocal, so let's go ahead and expand this out. I have 5.3 times 10 to the negative third power, so that's 5.3 times 1/10 times 1/10 times 1/10. So this, we can see that this really represents 5.3 times 1/10 repeated 3 times. And we already know something about what happens when we multiply by 1/10 that makes multiplying by 1/10 really easy. What happens when we multiply by 1/10? Feel free to look at your notes, Blanca. What happens when we multiply by 1/10? Feel free to look back at your notes. Yeah, the decimal moves once to the left. So that means that if we're multiplying by 1/10 3 times, then we should be doing what? Kenneth.
Moving the decimal to the last 3 times.
Good. All we need to do is move the decimal left 3 times. 1 for each multiplication of 1/10. So what that looks like is 5.3 times 10 to the negative third. Tells us we're starting with 5.3. And then I'm multiplying by 1/10 3 times. So move it 1, 2, 3 times. Fill in your place values. Go back and erase the original decimal point so there's no confusion. I get 0.0053. So again, we see that negative exponent is really just telling us in this particular case to multiply by 1/10, which is a super easy multiplication. So here I have 4 times 10 to the negative third power. Thinking about relative value. Is this going to be less than 1 or greater than 1? Yeah, it's going to be less than 1 because we have all these multiplications of 1/10. So we're going to write less than 1. In fact, all of these have the multiplications of those 1/10, so they're all going to be less than 1. And so I start with 4, thinking about it as like 4.0, my decimal's over here on the right. Make sure you get that decimal place value correct on those whole numbers because that starting point is where people usually mess this up. And so I have times 10 to the negative third, which means I'm multiplying by 1/10 3 times. Destiny, what do I need to do to get this in standard form? How many times? And what is that? What's the easy way of doing that? Yep, moving the decimal 3 places to the left. So I'm going to go back and erase my original decimal point so there's no confusion. And I find out that this is 0.004. Same thing with 6.3 times 10 to the negative fourth. That's multiplying by 1/10 4 times. 1, 2, 3, 4 moves of the decimal. Go back and erase my original decimal point so there's no confusion. This is 0.00063. And finally, 3.06, again times 10 to the negative 6. So those are representations of all those multiplications of 1/10. Move the decimal to the left 1, 2, 3, 4, 5, 6 times. Fill in your place values. And you get 0.000. Go ahead and erase that original decimal. 0.0000306. Okay? Oops.